This homework, we're going to be reading each statement, and then we're going to practice writing the correct formula for the substance that is indicated. We're going to replace the word and or plus with the symbol plus, and then replace produces with an arrow pointing towards the right. And then we're going to count the total number of atoms of each substance. So in the first example, we had lead 2 nitrate and potassium carbonate, which form lead 2 carbonate and potassium nitrate, and those are written correctly. And then we had to count up each of our atoms. So looking at the left side of the equation, the reactant side, I had 1 lead and I had 2 nitrogens because that 2 distributes inside the parentheses. And then I had 9 total oxygens, which came from 3 times 2. So I had 3 times 2, and then I had 3 more oxygens over here, and that's where I got the 9 from. I had 2 potassiums and I had 1 carbon, and on the other side I had 1 lead, 1 nitrogen, 6 oxygens because I had to add the 3 plus the 3, 1 potassium and 1 carbon. So we're going to try to replicate that each time we do one of these, so you get the idea about counting atoms. So let's go ahead and get ourselves started then with the first one. Aluminum and oxygen make aluminum oxide. So I have some aluminum, symbol Al, and some oxygen, which I have to remember is diatomic, so I write it as O2, and I'm going to make, so there's my arrow, aluminum oxide, and I'm going to recognize that that is an ionic compound, and I'm going to have to correctly put together the charges of Al3 plus and O2 minus. So crisscrossing my charges, because they do not cancel, I end up with Al2O3. Counting things up, I have 1 aluminum on the reactants and 2 oxygen on the reactant. On the product side, I have 2 aluminums and I have 3 oxygen. So I can very definitely see that this reaction is not balanced. Don't worry, we're coming back to balancing it. Then we look at the next one, sodium hydroxide. And so I need to make sure that I write everything correctly. Sodium is Na1 plus, and hydroxide is one of our polyatomics. It's OH1 minus. So I don't have to crisscross my charges, and I have NaOH. And the word and means I'm going to put a plus symbol, and then I'm going to have to correctly put together my hydrogen and sulfate, which is one of my polyatomic ions, making me have to crisscross, so I'm going to end up with H subscript 2 SO4. And if it makes you more comfortable to include your polyatomic with the parentheses around it, it's okay for you to do that as well. And then we're going to produce, so that's going to be our right-facing arrow. And now we're going to put together some sodium sulfate. So Na1 plus and SO4 minus 2. So we're going to end up with Na2 SO4. And I'm going to leave the parentheses just so that you can see your polyatomics. And then we're going to have some hydrogen hydroxide. So that is a tricky terminology, because what that is the combination of hydrogen and hydroxide. And if you put that together, you see right away, oh, I have 2 hydrogens and 1 oxygen. It would have been far more straightforward if we just called it water, but hydrogen hydroxide is what that is. So, okay, so the next thing we have to do is count up what we have. So on the reactant side, I have 1 sodium, and I have a total of 1 plus 4 oxygens, so I have a total of 5 oxygens, and I have 2 hydrogens. On the product side, I have 2 sodiums, I have 1 sulfur, and I just realized I left sulfur out over here, so I have 1 sulfur over here as well, and I have 4 plus 1 oxygen, so I have 5 oxygens, and I have 2 hydrogens. And this time I can see that, in fact, I do not have a balanced equation. Actually, I think I do have about everything is the same. So that one would be considered a balanced equation because it has the same number of atoms on each side. Okay. The next one I have is iron and copper 2 chloride. So I'm going to write iron. That's going to be plain old Fe. The word and means plus. Copper 2 chloride means I'm going to combine copper 2 plus and chlorine minus 1. So I end up with CuCl2 because those have to be crisscrossed. and I'm going to make, so there's my right facing arrow, iron 2 chloride, and I'm going to have to crisscross my charges, so I get FeCl2 and just some plain old copper, so Cu. I don't put any subscript 2's next to these single metals because they are not our diatomic things. So now I'm just going to count things up. I have 1 iron here, I have 1 copper here, and I have 2 chlorines here. Again, on this side, I have 1 iron here, I have 2 chlorines here, and I have 1 copper here. So this one turns out to be balanced as well. Okay. Okay, so let's go ahead and move on to question number 4 and taking a look at potassium chlorate producing potassium chloride and oxygen. Okay, so if we have potassium chlorate, we need to make sure that we write potassium chlorate correctly. And so potassium is K1 plus, and chlorate is ClO4, so ClO3, excuse me. Potassium is K1 plus, and chlorate is ClO3, 1 minus, and the charges cancel out. So I have ClO3, and I've got to put together potassium chloride, which is K1 plus and Cl1 minus, so I have KCl. And I have some oxygen, O2. All right, and I can see that I have K is equal to 1, Cl is equal to 1, and O is equal to 3 atoms on the reactant side. On the product side, I have K is equal to 1, Cl is equal to 1, and O is equal to 2. So this one in particular is not balanced. Okay, don't worry, we'll come back to those balancings. Okay, so we go look at the next one, and magnesium and silver nitrate are making magnesium nitrate and silver. So I'm going to write magnesium and silver nitrate, which I know silver is always +1, and I'm putting it together with nitrate, so I get AgNO3. And I'm going to form some magnesium nitrate. Magnesium is 2 plus, NO3, 1 minus. Crisscrossing my charges, I get Mg, NO3, 2, and I've got some silver, Ag. Okay, so then I'm going to count things up. I have magnesium is equal to 1, silver is equal to 1, nitrogen is equal to 1, and oxygen is equal to 3. On the opposite side, I have magnesium is equal to 1. I'm going to remember to distribute my charges. So the 2 goes to the N, and the 2 also goes to the O. So I have nitrogen is 2, oxygen, however, is 6, and silver is just 1. So this one is definitely not balanced as well. Okay, so the next one I have is silicon tetrachloride, and this one is a covalent molecule, and I know that because it's using prefixes and because silicon and chloride are both nonmetals. So that means I have 1 silicon and I have 4 chlorines. So silicon tetrachloride is going to produce silicon and chlorine happens to be one of my diatomic molecules, so that is my equation all written out. And for this I have 1 silicon and 4 chlorines. On the product side I have 1 silicon, but I only have 2 chlorines. Definitely not balanced as well. Okay, then we have number 7, and number 7 says I have sodium sulfite and calcium chloride, making calcium sulfite and sodium chloride. So here we go. I have sodium, Na1 plus, and sulfite, SO3 minus 2. I have to crisscross my charges, so I end up with Na2, SO3. To that, I'm going to add some calcium chloride. Calcium is 2 plus, chlorine is minus 1, so I have CaCl2. And then I have calcium with a 2 plus charge and sulfite with a 2 minus charge, so I have CaSO3. And then I have some sodium chloride, which you know is Na1 plus and Cl1 minus, so that's NaCl. When I'm adding this all up, I have 2 sodiums, 1 sulfur, and 3 oxygens. And let's see, 1 calcium and 2 chlorines. On the opposite side, I have 1 calcium, 1 sulfur, 3 oxygens, 1 sodium, and 1 chlorine. So this one is also definitely not balanced if I were to add all those up. Okay, so let's take a look at questions 8, 9, 10, and 11. All right, so on this one I have diphosphorus pentaoxide. So diphosphorus means I have P2, and pentaoxide means I have 5 oxygens, and I have barium oxide. Barium is Ba2 plus, and oxygen is 2 minus, so I have BaO because the charges cancel out, and they are going to make barium phosphate. Barium is 2 plus, and phosphate is one of my polyatomic ions, and it has a -3 charge, so I end up with Ba3PO4 2. If I'm counting this all up, I have 2 phosphorus, 6 oxygen when I add 5 plus 1, and 1 barium. On the opposing side, I have 3 barium, 2 phosphorus, and 8 oxygen, so definitely not balanced here as well. Going on to the next one, I have calcium, Ca, being added to water, and I am making some calcium hydroxide after I crisscross my charges, and hydrogen. Be sure you remember hydrogen is one of our diatomic molecules. If I'm counting everything up, I have 1 calcium, 2 hydrogens, and 1 oxygen on the reactant side, and I have 1 calcium, 2 oxygens, and 4 hydrogens on the product side. Then I go on to number 10. I have iron 2 oxide. That is going to make me FeO when the 2 plus and 2 minus from the oxide cancel out. And I have some hydrogen chloride, which makes HCl when H1 plus and Cl1 minus cancel out. And then this is going to make iron 2 chloride, which is going to come out after I crisscross to FeCl2. And that silly thing, hydrogen hydroxide, which we all have learned now, is just plain old water. Okay, so now I'm going to count things up. I have 1 iron on each side, and I have 1 oxygen on the reactant side and 1 oxygen on the product side. I have 1 hydrogen on the reactant side, but I have 2 hydrogens on the product side, and I have 1 chlorine on the reactant side, but I have 2 chlorines on the product side if I were adding them all up. Also, another one that is not balanced. So that one was not balanced, as this one is also not balanced. Okay, let's go ahead and finish this up. I have number 11, 12. We have a lot of these, so yay for us having so much work to do. Let's go ahead and see if we can finish these up. So I have ammonium chloride, which should be written as ammonium, which is NH4, 1 plus, and chloride, which is 1 minus, so those cancel out. I have barium hydroxide. Crisscrossing my charges, I come out with BaOH2. I'm going to produce ammonium hydroxide. Ammonium has a 1 plus, hydroxide has a 1 minus, so both of those cancel out. So we have NH4OH, and I end up with barium chloride, which is BaCl2 after I crisscross my charges. Then I'm going to count things up. I have 1 nitrogen, and I have a total of 6 hydrogens after I add the 4 plus the 2. I have 1 chlorine, and I have 2 oxygens and 1 barium. Ba is barium. On the product side, I have 1 nitrogen. I have a total of 5 hydrogens. I have 1 oxygen, I have 1 barium, and I have 2 chlorines. So this is definitely not balanced. Okay. Then I have potassium nitrate, so that is KNO3, producing potassium nitrite, KNO2, and oxygen, and I have to remember to use my oxygen as a diatomic. Counting things up, I have 1 potassium, 1 nitrogen, and 3 oxygens. On the opposing side, product side, I have 1 potassium, 1 nitrogen, and 4 oxygens, so this is not balanced again. Then number 13, I have nitrogen monoxide, so that's NO, and I'm putting it together with some oxygen, remembering it's diatomic, O2, and then I'm making nitrogen dioxide, which is NO2. I'm going to have 1 nitrogen and 3 oxygens on the reactant side, and I'm going to have 1 nitrogen and 2 oxygens on the product side. Number 14, I have copper plus oxygen, which is diatomic, to make copper 2 oxide, which is Cu2 plus and O2 minus, so I get CuO. I have 1 copper and I have 2 oxygens on the reactant side, and I have 1 copper and I have 1 oxygen on the product side. Neither one of these last two are balanced, so they will need to be balanced. Let's go ahead and move on. I think we're getting close to the end here. 15, 16, 17. We have to make it all the way to 19. Okay, so here we go. 15, 16, 17. I have iron 2 hydroxide or iron 3 hydroxide crisscrossing the Fe3 plus. I end up with FeOH3, which is going to decompose into iron 3 oxide, Fe crisscrossing my charges, Fe2O3, and making some water. Counting things up, I have 1 Fe, 3 oxygens, and 3 hydrogens. On the product side, I have 2 Fe's, I have 4 oxygens, and I have 2 hydrogens. So not balanced. Number 16, I have calcium oxide and sulfur dioxide, writing it with my prefixes, and that makes calcium sulfite, and both of those charges cancel each other out, so I end up with CaSO3. Counting things up, I have 1 calcium, a total of 3 oxygens, and 1 sulfur, and on the product side, I have 1 calcium, 1 sulfur, and 3 oxygens. So this one is already balanced because the number of atoms on each side are equal. And then number 17, I have some magnesium reacting with some hydrogen nitrate, which is H1 plus and NO3 1 minus, so HNO3. And this is going to make magnesium nitrate, crisscrossing my charges, and hydrogen, which I'm going to remember is diatomic. If I count things up, I have 1 magnesium on the reactant and I have 1 magnesium on the product. I have 1 hydrogen on the reactant and I have 2 hydrogens, 2 hydrogens on the product. Then I have 1 nitrogen on the reactants and I have 2 nitrogens on the product. And I have oxygens are 3 on the reactants, but oxygens are 6 on the product. So definitely not balanced there. All right, 2 more for us to do to be all done here. Number 18 and 19. Okay, so number 18, zinc carbonate. Zn, crisscross the charges. Nope, we don't have to. Zn is 2 plus, CO3 is 2 minus, producing zinc oxide, which is ZnO. Charges cancel again. And some carbon dioxide. When I count things up, I have 1 zinc and 1 zinc, 1 carbon and 1 carbon, 3 oxygens, and 1 plus 2 equals 3 oxygens. So we're already balanced for this one. All right, last problem. Calcium sulfate gives us CaSO4 because charges cancel. Sodium carbonate, we do have to crisscross charges, so I end up with Na2CO3. And I'm going to make some calcium carbonate where my charges will cancel because I have Ca2 plus and CO3 2 minus. And I'm going to have some sodium sulfate where I do have to crisscross my charges, and I get Na2SO4. Counting things up, I have 1 calcium on each side, I have 1 sulfur on each side, I have a total of 4 plus 3 equals 7 oxygens, and I have 2 nitrogens and 1 carbon. I also have 1 carbon on the product. I do have 2 nitrogens on the product, and look at that, I have 7 oxygens from 3 plus 4 oxygens. So this one is also balanced as well. Okay, everybody, thank you very much.